Welcome to this lecture on solving projects in data structures. The topic today is to cover a roadmap of pieces of advice that I have for you on how to solve any project that I give you in this course. And we'll cover them in this order. We're going to start with understanding what you're supposed to solve. Then prepare test cases. After you've prepared test cases, then write your solution. Once you are convinced it's correct, submit your solution, your program, to the upload site for testing. And if it's wrong, then debug your program and use the scientific method to do that. So we'll delve into all of these in this lecture. First of all, start with understanding. Before you write anything, any code at all, read the project description, the whole thing. And I would emphasize, read it quickly so that you get a sense for the whole thing and you don't get stuck in any one part. So read it quickly. After that, read it again, but this time focus on what you will be provided as input and what you need to provide as output. Look at the code that's provided, the code that is given as some header files or some sample implementation that you need to fill in. As you're doing this, as you're reading through these things, make some notes, either on paper or on a document, about what's not clear, okay? And reread those things. Reread the descriptions of those things until they become clear, okay? And if you have questions, you can ask, but the first thing I will ask you is, have you read the project description and have you read it and reread it multiple times? Because the information is there. It might not make sense to you at first, but the information that you need is there in the project description and in the related documents. For every project that I give you, there's going to be a professor's executable. This is a binary program, a program that I've compiled and I provide to you that you can run on your own computer, and you can run it to compare how your program is behaving versus how my program is behaving on a particular input. I've also provided for you sample test case inputs. You should run my program on those sample cases and your program on those sample cases. They give you a sense of what the input will look like, okay? The next step, after you've read and understood the project description, is to prepare test cases. I just mentioned the sample test cases. They are not sufficient. They are not sufficient for getting you to finish this project. They illustrate a few examples of what types of input you might see, but they don't cover every test case, every corner case, every difficult case. So you should not rely on those only. You should write by hand or in a document some small cases, okay, some small test cases. Each test case is just a simple text file that you fill in with the input and just that input for that test case. And each test case should exercise or test a particular thing. You can also write a program, hopefully a small program, to generate for you larger test cases so that if you want to test with a large test case, which is a good idea, you don't have to write that large test case by hand. You could write a small program which generates a large test case, which you can put into a file and run your program on. When you write test cases, make sure that you follow the input format carefully. As you'll see, my executables that I provide for you will reject any input that is not carefully formatted. So if my program crashes, the sample executable I give you, if you download it and run it on something that you wrote and it crashes, that's probably not a bug in my program. It's probably a bug in your sample or in the input file that you created, okay? Because it just rejects outright anything that's not formatted correctly. So when you're writing test cases, make sure you follow the input specification as well. As I said, use the downloadable professor's executable to get the correct output for correctly formatted inputs. So when you write a test case, you write the input file. You don't have to write the output file. You could just feed it into my executable and get the correct output, okay? And the goal here in making test cases, before you even write any code, is you make cases that really test your program. These are not just things that you do just to say that you've done them. What you're trying to do here is write test cases that actually test the boundary conditions, the edge cases, big cases, small cases, everything in between, so that you are sure that your program is running properly. After you've written your test cases, so now you have a handful of text files, say 10 test cases that you've written. Then write your code, and you should write it slowly and piecewise. When I say piecewise, I mean focus on one portion and then focus on a different portion. Don't write the whole thing in one big session. Okay. If there are milestones for the project, which most projects will have milestones, follow those. Follow the order that they instruct you to solve the problem in. Test your project as you go. Use your test cases wherever possible. Okay, so it's much easier to write a little bit of code and test it and make sure it's working properly, and then write a little bit of code, test it separately, and make sure it's working properly, and then put those things together than it is to write a whole bunch of code, test it, it doesn't work. Well, where isn't it working? It could be any of these subparts. So test each subpart as you go, and the milestones are designed to have you do that. Also, you should use input and output redirection and diff. I'm going to talk about these quite a bit in another lecture, so look for those in another lecture. But briefly, you can write input and output redirection is running your program from a command line, and input redirection looks like this. You have your program, and you use the less than sign and then the file name. Okay, and that tells your computer to run your program with this file on, which is in the same directory possibly, as the standard input. So you don't have to open the file and read it. It just gets shunted into the cin, the standard input. And you can also redirect the output of your program to the to a file. Let's call it out. Okay, and then this will capture the output to a file as well. And then you can compare the output of your program, which you captured here, with the output that my program gave you with what's called a difference utility. And that compares those two output files bit by bit, character by character, and tells you whether they're different, which is highly useful. But again, all of that is gone into more detail in a future lecture, so look for that. Once you've written your solution, if it's correct, well, how do you know if it's correct? You upload it to the upload site, you click test, and what I like to call the robot wakes up from its slumber and starts testing your program on, or your submission, on a number of hidden test cases. And it might have dozens, if not hundreds, of hidden test cases, which you unfortunately don't get to see. Suppose that the robot says, I put my stamp of approval, it ran quickly, and it gave the correct answer for everything, then that's great, okay? Then it's on to the style check, and I'll talk more about that in a second. Style check is where I just check your code to make sure it follows proper style. But let's suppose that your code did not pass the robot's test cases. If it's incorrect, what do you do? Well, how do we deal with incorrect code? What kinds of errors might you encounter when you click test on the upload site? Well, the first thing that you might see is you might see incorrect output. So you might get a response back that your program just gave the incorrect output. And the robot is very picky here. If it expected a space and you gave it 2 spaces, that's not correct. So it's very picky, okay? It could be that and this is the most common thing that you might tend to see if your program is incorrect. It might take too much time. If the robot sees that your program is taking a long time, it's going to stop your program from executing and say, you don't get to go on, it took too much time. But the limits that it gives you are generous. So if your program is taking too much time, it's likely that there's an infinite loop in your program, so look out for that. It could be that your program did not pass because at some point it crashed. And if it crashed, it could be due to your own assert, which is a good thing, which I'll talk about in a later lecture, or it could just be that you had some sort of bug in your program and it crashed, okay? Or it could be that your program used too much memory as it was going. And again, the robot said, that's enough, you can't have any more memory, you've got to stop, okay? If your program fails due to one of these errors, what do? Well, you do not do this. You do not come to me or someone else and say, well, my program works on my computer. Okay, great. It doesn't work on the robot, though. It works on all my test cases. Yes, but the robot has different test cases that it's not sharing with you, unfortunately. Okay. If the robot has a test case which shows that your program is incorrect, that means your program is incorrect. Okay. Just because you don't have that test case doesn't mean that it is correct. But the good news is you get to shape and form whatever test cases you want, which was 2 steps ago, right? That was the second step. After reading, you write your test cases. So you can go back and write more test cases. Don't just say, I can't figure it out, okay? Apply some discipline here and try to think what could be causing this problem, okay? And you don't just ask me the question, why doesn't it work? Okay, because I'm not going to come out and just tell you why it doesn't work. I might give you some hints, but my job here is to get you to find out why your program, which you wrote, is not behaving correctly, okay? So the next thing I'll say is I encourage you to adopt a view of humility about your own programming abilities. I think that everyone as a programmer should adopt a posture of humility. I write programs all the time that are incorrect, and I make much better progress if I accept that they are incorrect and look to how to fix them. And so adopt a posture of humility and accept the fact that your program may in fact be incorrect and the robot is just informing you of that fact. So it's actually helping you here. Okay. So how do we actually deal with this? Well, as I hinted at, let's use the scientific method. And the scientific method is the following. Form a hypothesis. Okay. A hypothesis is a specific thing, not just my program is wrong, but it's wrong because of X. And here's a sample hypothesis. My program is not parsing the last input line correctly. That's a hypothesis. A hypothesis is something that we can test, and we can test it by making a test case. So you write a test case which tests that hypothesis. You run your program and my program on that test case, and you compare the output of your program and my program. Are they the same? If so, your program is behaving correctly on that test case. That doesn't mean your program's correct. That just means that that test case didn't show what was incorrect. Okay? So your goal here is to find a test case that causes your program to do the wrong thing. Okay? And when I say that, I mean a valid input that causes incorrect behavior on your program's part. Okay? So the test result for this test case could be that your program fails. In other words, it gives a different output or a different behavior than what the sample executable does. That's actually a really good thing. Why is that good? Well, because you have written a test case that shows what, that illustrates or that brings out the bad behavior of your program. So now all you have to do is trace through your program and figure out why it's behaving incorrectly. If you can't trigger the bug, you can't identify how to fix the bug. If you don't know what the bug is and you can't trigger it. Now, if your program succeeds on that test case, as I said before, that doesn't show you anything. You know that your program's wrong. You need to try another hypothesis. So form another hypothesis, make a test case for that hypothesis, and test again. And again, in all of this, in the scientific method testing, your goal is to show that your program is incorrect, not to show that it's correct, okay? Here is a flow chart, which you'll also see on my website, that shows you kind of all of this that we've talked about so far. After you read the project, you're going to make test cases, and then you write code, and then you test your code thoroughly with the test cases that you made up here. If you find a bug, then you debug using the scientific method, and you go back and make test cases, and you keep going through this loop. If you have successfully defended your code against all bugs that you can find, then if there's not a bug, then you can go up here and upload your code, click test on the robot, and the robot will churn away for a while, and it'll either tell you, yes, your program passes, or no. If it's no, then you have to go back into this cycle and identify a hypothesis and test that hypothesis to show what's wrong, okay? But if the robot says, yes, your program behaved correctly and gave all the correct outputs, then it goes to what I call a style check. So all of this is in the robot automated, and this is me. I'm not a robot, I'm not automated. And I do a style check to look at your code and make sure that it follows the style guidelines, which you can read about. If the style check fails, in other words, if I tell you, you have to fix these things, you need to go back, write the code, test your code, re-upload and test again, okay? So what I'm trying to tell you here is that if you fail the style check, you need to go through the robot's tests again to trigger another style check, okay? Once you pass the style check, you are done, okay? And it's the time at which you click test right here that determines your grade for the project. The time at which you click test relative to the deadline of the project. So if you click test before the deadline and you pass the robot and you pass the style check, the fact that you clicked test before that means you get 100%, okay? A few more tips. Think about the boundary cases when you're developing test cases, from very small, and when I say very small, I mean, I think about what's the smallest valid input, to very large. Very large test cases tend to test things that you wouldn't normally run into, and smaller ones puts your program through a lot more stress because just the amount of data that it has to deal with. When you're testing here, as I said before, focus on the bugs. Focus on the bugs. Focus on the wrong behaviors. Don't waste your time testing things that you know are correct. Don't do that. Writing test cases for test cases' sake is not the goal. The goal is to write a test case that shows incorrect behavior. So when I was young, I participated in a skit which illustrates this, I think, quite well. The scene is a dark night on a corner with a street lamp. And there are a whole bunch of people gathered together. And one person says to the other, "So where did you lose your keys?" And the person who is looking for their keys says, "Oh, way over there." And the first person says, "Well, then why are you looking here?" And the second person says, "Well, because this is where the light is." Okay. Now this is part of a much longer sketch, but I distilled it here for you. Don't look where the light is, look for where your keys are, right? Don't hunt bugs that aren't there, hunt bugs that exist by writing test cases that actually test the issue at hand. Last tip that I'll give you on this slide is you might not be able to replicate exactly what the robot is telling you. Okay, if the robot tells you your program crashed in this way, you might not be able to replicate exactly that type of crash on your computer. That's okay. Why is that the case? Because you have a different computer than the robot, a different operating system, a different compiler, and of course, the robot has different inputs, test cases than you do. So don't make it a goal to replicate exactly the same incorrect behavior. What you're going for is there's a bug, the robot triggers it in one way, you should be able to trigger it in some way on your computer. So just focus on trying to create test cases that cause bad behavior in your program. Okay. Last thing I'll say about making test cases. Suppose that you have written a program because you wanted to write a program that generates very large test cases, and you have this, 10,000 line input that causes your program to crash. Okay. The correct response is yay. And the reason it's yay is because, well, that's a test case that you can use to debug your program. However, how do you find out what's wrong? If the input is so large, it's got 10,000 lines, how do you find out where in those 10,000 lines the error in your program is? Well, you could try to chop down, my advice is that you chop down that large test case into a smaller test case that causes a similar problem. Because inside a large test case that causes a problem is a much smaller test case usually that causes the same problem. So your job then is to take this large and useful test case, but hard to understand test case, and chop it down into a very manageable size so that you can understand the test case. Okay, and one way of doing this is divide and conquer. Okay, divide and conquer meaning if your test case is this big, right, 10,000 lines long, maybe if it's possible, you cut it in half and keep only this portion, okay? If that's still a valid test case, then you test with just this portion. And if the bug still occurs with just this portion up here, then you've just cut in half the size of the test case and you can do it again, okay? Now, if you cut it in half and the bug goes away, guess what? You needed to keep those two halves together. So you need to find another way of cutting down your test case. But the point is, try to throw away large portions of your test case while keeping a valid test case and make it much smaller, because inside of a large test case that causes a bug to be triggered is a small test case that causes a bug to be triggered. I've said enough already. I think I've taken up enough of your time, so I'm going to stop here. But hit me with any questions you have, and I'll see you on the next lecture.